Hello everyone, I'm Spandana Gautam from Mechanical Engineering, second year, regular. Today we'll be discussing about the construction and working principle of a synchronous generator. In this session, we'll be discussing about the history of generators and what does the word synchronous refer, what is meant by a synchronous generator and its construction and the working principle. Last, what are the applications and what are the advantages and disadvantages of the synchronous generator, and last we'll conclude the synchronous generator. When it comes to the history of generators, before the connection between magnetism and electricity was discovered, electrostatic generators were invented. They operated on electrostatic principles by using moving electrically charged belts, plates, and discs that carried charge to a high potential electrode. The charge was generated using either of the two mechanisms. One is electrostatic induction or the tri-bioelectric effect. Such generators were high voltage and low current. Because of their efficiency and the difficulties of insulating machines that produced very high voltages, electrostatic generator has low power ratings and were never used for the generation of the commercially significant quantities of the electric power. Their only practical applications were to power early X-ray tubes and later in some atomic particle accelerators. The operating principle of electromagnetic generators was discovered in the year 1831 to 1832 by Sir Michael Faraday. The principle later called Faraday's law is that an electromotive force is generated in an electric conductor which encircles a varying magnetic flux. In 1860s, AC and DC generators were invented, and by the 1870s, the AC and DC generators were produced to run an outdoor lighting system called candle. By 1879, Thomas Edison had invented a light bulb. Edison also invented a DC generator, which was first installed in New York City in 1882. Here are some famous personalities or inventors of our electric power system. Here you can see Sir Nicholas Tesla and William Thomson, sir, and Charles Brush. Sir Charles Brush. These are some famous personalities who dedicated their lives for our electric power system. And the oldest and the first generator that was built by Sir Michael Faraday. It's an hand cranked copper disc. This small teeny construction is the hand cranked copper disc, which is placed between the poles of a permanent magnet to make it as an or to work it like an electric generator. This is the construction of an electric generator at that time. This was the first generator that was constructed by Faraday, sir. And here we'll be placing this small constructed hand cranked copper disc in this setup, which is placed between the poles of the permanent magnet so that it becomes an electric generator. And when it comes to the history of the synchronous generator, the real beginning was in 1880s. First, a fixed pole was used with the pole surrounding a rotating annular armature. This was called the external pole type. An important milestone was the three-phase generator derived from a DC motor with the Thomson armature. And a German scientist is the first one to come up with the idea to use the three-phase alternating voltage and current system in July 1887. He builds the first three-phase synchronous generator with silent poles. And what does a synchronous mean? Synchronous is an adjective that is defined as occurring at the same time or simultaneously. In general, synchronous is used to describe the things that happen at the same time. The synchronous generator is so named because it is only at synchronous speed that it functions properly. So it is synchronous speed is like simultaneous speed, and we'll see this later. For now we define synchronous speed as the speed for which the induced voltage in an armature or a starter windings is synchronized with the network voltage. Synchronized refers to the having same frequency, and synchronous generator also refers as the alternators or AC generators. The term alternator is used since it produces AC power, so it is called synchronous generator because it must be driven at synchronous speed to produce AC power of the desired frequency. So here we are having another two names for the synchronous generator. One is alternator and the other one is AC generator. And when it comes to the construction of a synchronous generator is a synchronous machine which converts mechanical power into AC electric power through the process called electromagnetic induction. And synchronous generator also referred as we have seen it, right? It is also called as alternators or AC generators. The term alternator is used since it produces AC power. It is also called a synchronous generator because it must be driven at synchronous speed to produce AC power of a desired frequency. A synchronous generator can be either single phase or polyphase. Generally when it comes to the polyphase, it is like a three-phase synchronous generator, as alternator consists of two main parts. One is starter and the other one is rotor. We'll know about starter. A starter, the name just indicates like a stationary thing. The starter is a stationary part of an alternator. It carries the armature winding in which the voltage is generated. The output of the alternator is taken from the starter. When it comes to the rotor is also, it's by the name we can say it's like some rotating thing. The rotor is the rotating part of the alternator. The rotor produces the main field flux. When we go some deep, it's like a starter construction. The starter of the alternator includes several parts like the frame, starter core, starter or armature windings, and cooling arrangement. The starter frame may be made up of a cast iron for small size machines and welded steel for the large size machines. The starter core is assembled with a high grade silicon content steel laminations. These silicon steel laminations reduces the hysteresis and the eddy current losses in the starter core. The slots are cut on the inner periphery of a starter core. A three-phase armature winding is put in these slots. The armature winding of the alternator is a starter connected. The winding of each phase is distributed over several slots. When current flows through the distributed armature winding, it produces essential sinusoidal space distribution of EMF, electromotive force. And here you can see the constructive figure of a starter of an alternator. This is the laminated and slotted starter core. It represents like this. Here you can see it in the figure. And we'll discuss about the rotor construction of an alternator. The rotor of the alternator carries the field winding, which is supplied with direct current through two slip rings by a separate DC source. This DC source is also called as exciter. The exciter is generally a small DC shunt generator mounted on the shaft of the alternator. For the alternator, there are two types of rotor constructions. Here, in this rotor, we can see another two types of constructions. One is silent pole rotor, and the other one is cylindrical rotor type. First, we'll know about silent pole rotor. The construction of the silent pole rotor type cannot be made strong enough to withstand the mechanical stresses to which they may be subjected at the higher speed. If the silent field pole type rotor is driven at a high speed, then it would cause windage loss and would tend to produce noise. We'll Now we'll be able to know some more interesting things about the cylindrical rotor. The cylindrical rotors are made from the solid forgings of high-grade nickel chromium molybdenum steel. The construction of the cylindrical rotor is such that there are no physical poles to be seen, as in silent pole rotor. In about 2/3 of the outer periphery of a cylindrical rotor, slots are cut at regular intervals and parallel to the rotor shaft. The field windings are placed in slots and is excited by the DC supply. The field winding is of a distributed type, and the unslotted portion of the rotors forms the pole faces. It is clear from the figure of the cylindrical rotor. Here you can see the figure. In this figure we can see that how DC supply of a cylindrical rotor can be done. That when the figure of the cylindrical rotor, that the poles formed are non-silent, they do not project out from the rotor surface. And the cylindrical type rotor construction provides a greater mechanical strength and permits more accurate dynamic balancing. It gives noiseless operation at high speed because of the uniform air gap, and the flux distribution around the periphery of a rotor is nearly a sine wave, and hence a better EMF, electromotive force waveform, is obtained. Here in this picture you can compare the construction of a cylindrical pole rotor and the silent pole rotor. Here you can see some similarities between them, like the armature winding slots are similar, and rotor field winding. These two are the rotor field windings of the both cylindrical and silent poles. Okay, now we came at the most interesting part: working principle of a working principle and the operation of an alternator. You know what does an alternator means? It also known as synchronous generator, right? So this alternator or AC generator or a synchronous generator works on the principle of electromagnetic induction. That is, when the flux linking conductor changes and EMF is induced in the conductor, when the armature winding of an alternator is subjected to the rotating magnetic field, the voltage will be generated in armature winding. When the rotor field winding of an alternator is energized from the DC exciter, the alternator N and S poles, north and south poles, are developed on the rotor. When the rotor rotated on the anti-clockwise direction by the rotor poles, as a result, the EMF is induced in the armature conductors due to electromagnetic induction. This induced EMF is alternating one because the north and south poles of the rotor passes in the armature conductors alternatively. The direction of the generated EMF can be determined by the Fleming's right hand rule, right? And the frequency of it is given by F is equal to Ns into P divided by 120, where Ns is the synchronous speed in Rp, like reverse power. Here Rp is the reverse power, and P is the number of rotor poles, and the magnitude of the generated voltage depends upon the speed of rotation of the rotor and the DC field excitation current. For the balanced condition, the generated voltage in each phase of the winding is same but differ in phase by 120 degrees electrical. Here you can see the detailed construction of a synchronous generator. Here you can observe what is yoke. Yoke is the outermost. It's like a protective layer that surrounds a generator. Its yoke and small winding like structures, these are called starters, and this is the three-phase DC supply, and this is the rotor winding. Here you can see the south pole and the north pole, and this is the base of a generator, and this is the rotor, and this wire-like structures are called rotor windings. And when it comes to the applications of synchronous generators, small synchronous motors are used in timing applications such as synchronous clocks, timers in appliances, tape recorders, and precisions, in which the motor must operate at a precise speed. Accuracy depends on the power line frequency, which is carefully controlled in large interconnected grid systems. Synchronous generators are commonly used for variable speed wind turbine applications due to the low rotational synchronous speeds that produce the voltage at grid frequency. Synchronous generator can be an appropriate selection for variable speed operations of wind turbines. Here you can see the 3D model of the 3D representation of a synchronous generator, and the most easy representation of a synchronous generator can be represented like this, it's a starter, and this is the representation of a rotor, and this is the base of a generator. Here you can see the simplest form of representation of a construction of a synchronous generator. And when it comes to the advantages of the synchronous generator, one advantage of the synchronous generator is that it can produce utility type power without an external power grid. The unit must provide its own voltage and frequency control and not depend on the utility. Maximum reliability over time, simplicity in use and maintenance, brushless and equipped with the AC synchronous generator, trip-proof machine, high power to weight ratio, low rotor inertia for high accelerations, high efficiency. These are some advantages of the synchronous generator. Here you can see the another construction of a synchronous generator. Here you can see one exciting thing, that is excitation voltage and two pole rotors. This is one type of representation in the synchronous generator. And when it comes to the disadvantages of a synchronous generator, these synchronous motors have a number of disadvantages. Like when it comes to the cost, it is highly expensive, and the need for a separate power source for excitation and limited speed control, and its difficulty in starting, which makes them less ideal for the various industrial and commercial applications. They can also be used as generators or power factors correction. However, synchronous motors have some drawbacks, such as we discussed, its high cost and complexity and maintenance. They also need a separate starting device, such as variable frequency drive or a slip ring, to overcome the high starting torque and current. Here you can see the slip rings and the shaft and the rotor and the starter in this figure. This is the detailed representation of a synchronous generator. And now finally we came to the conclusion part. We'll conclude this as a synchronous generator is it's an AC machine where the speed of the synchronous generator, that is, its speed is proportional to the frequency of an armature. The rotor, with the magnetic field produced by the field current, they rotate at the same time or in the synchronism with the magnetic field produced by the alternate armature current. A synchronous generator is a synchronous machine which converts mechanical power into AC electrical power through the process of electromagnetic induction. Synchronous generators are also referred as alternators or AC generators. We discussed it now, right? The term alternator is used since it produces the AC power. These are some detailed pictures of the synchronous generator. This is about construction and working principle of a synchronous generator. Thank you for watching.